Hi class. Today we're going to talk about white balance, color temperature, and color theory. I'll be going through this presentation and discussing these different topics, and then from there I'll be going into a white balance demo in Lightroom and also go into color correction and just overall playing with some colors. So here we go. So I also found a great quote online. Again, this quote is from Cambridge in Color, and I thought it did a really great job of just talking about exactly what is white balance. So white balance is the process of removing unrealistic color casts so that objects which appear white in person are rendered white in your photo. Proper camera white balance has to take into account the color temperature of a light source, which refers to the relative warmth or coolness of white light. Our eyes are very good at judging what is white under different light sources, but digital cameras often have great difficulty with auto white balance, AWB, and can create unsightly color casts. So, talking about color casts, um, basically color casts, and I just wanted to kind of touch on this actually before getting into this. I know this talks about auto white balance, so we'll also get into that later in this presentation. And I also know that I've told you that you can use auto white balance when you're first starting and taking photos. That's just part of the class that I just didn't want you to have to think about right off the bat. But now definitely you'll see the limitations with auto white balance. And also you can choose different types of white balances on your camera. So moving forward, just something to point out there. All right, so color casts. Here we have some different color casts happening between warm light and cool light. As you can see here, warm are colors like yellow, orange, and red, and cool are colors like blue, purple, and green. So color casts happen everywhere, and they're basically colors that just reflect off surfaces. So it can be any color and it can literally happen everywhere. A good example is when you're outside looking at the sky, looking at the sun, and how those different color casts of the yellow orange sun are different from the cool blue sky. So in this photo right here, you can see this is around golden hour, right? The sun is setting. We can see that really bright orange color coming through and how that affects the space. And then on the other side here, this image of the sky, the blue sky is like, obviously this is a sunny day, but it's cloudy, it's got a blue sky, and that color cast from the sky is affecting the color that's coming in through the window and also shining through just as general light. You can see that the color of the light, daylight that's coming through is more white, and also which means that it's more cool. So there's no sense of warmth really coming in through this window versus the window on the left that has the warm sunlight coming through during sunset. So on top of that, like I said, daylight versus sunset, very different looks here. And then it also can happen from people wearing different colors and certain colors specifically. So we'll get into a couple examples, but I just wanted to further emphasize that it's, of course, color casts happen from different lighting sources. This can happen from natural light, artificial light, which we'll talk about, and also this can happen from literal colors reflecting off of surfaces like someone wearing a red shirt. So this is a common example, especially in like studio photography. When you are doing studio photography, you might notice that a lot of times if it's done in the studio, if it's done like a headshot for like a corporate client, we usually ask clients to not wear anything too bright to keep the colors neutral, because when we take photos in the lighting that we're using, so like in a studio, when you're using bright flash and strobes, things like that. This can also just happen in regular light. It doesn't have to be in the studio environment, but we try to avoid people wearing really bright colors. A good example is a bright red shirt. This would also happen with like bright green, pink, any bright color this would happen with. So you can see specifically in the shadows, there is a color cast happening. And I cannot, unfortunately, I can't zoom into this presentation, but you can see here in this person's neck, under their chin, in their arms here, you can see a red cast happening. So this is because the red shirt is reflecting off basically the light source that's going towards them, um, is then causing the shirt to reflect, and you can see that in the shadows. You can also, like I said, out of studio setting, you can see this when someone is just like in natural light, in the shadows of their face, you may see that the color is reflecting off of them as well. So another example, I think this was done with a reflector. That's also a studio accessory where you can change the reflector. It's like this fabric material that basically you can have like a cool or a warm side. So literally the reflector will be like gold or silver. And you may see this outside when you see people photographing portraits of people outside, maybe doing like senior photos. If they're like more of a, or maybe let's say if it's like a photographing team, they might have a reflector with them, and this bounces the light off from the sun or from another light, and it casts this color cast, or rather this glow of either gold, yellow, or a cooler tone that's happening here. This could also be done, I'm just guessing. To me, this looks like a reflector. To me, this looks a little bit more like color temperature on your camera and playing with it. So I'm not really sure what was done in this photo. And I make a lot of studio references because I'm a studio photographer. So that's why I just come from that background. So it's natural for me to talk about those types of things. But as you can see, be it the color temperature of your camera or the color temperature of the space, if a reflector was being used or not, just imagine like a metallic gold sheet, like a metal sheet that is gold, and if you put it in front of this kid's face here, um, you would see that gold reflecting off. So that's basically what a reflector is. But as you can see, whether it is whatever the different things that I've talked about, reflector, color temperature of the camera, you can see that this image is warmer and this image is cooler. And we can see that in the whites. And again, we can also see that happening in the shadows here. So look at the whites in this image on the right. Overall, the photo looks a lot cooler in temperature. Like it's pretty cold. It doesn't look very like warm and inviting. It gives off a different mood, a different feeling. I feel like you can kind of even see like more of the red popping out even more in this image because it's so cold. Um, and you can see here the white shirt in the shadows, there's this kind of green tinge. And also a big giveaway is also this table. Like, what is going on with this table? There is a lot of green happening on this table. So I'm imagining that this table is actually a white color because it also changes in this image, where this image is more of a yellow tone happening in the table. And also you can see that in the shadows, it's a lot warmer as well. So you can see how color casts affect the image. These are really extreme, these next examples. They're very extreme. And they're extreme for a reason because it's just like a really easy way to determine color cast. So as you can see, these white flowers, this is what it should look like without color cast, and this is what it looks like with a color cast. This image was most likely done in camera. So like the color temperature that they chose in camera was way too blue, and then the actual environment looked more like this, where the color of the flowers are like white, but they're also like a little bit more yellow. And so on the other side, this is definitely the wrong color temperature and color cast that's happening to this image. So if we ever have this situation happen, which you will experiment with, you can change the color, you can color correct the color and the white balance of the subject in Lightroom in editing. Next, we have another example of flowers. You can see that there is the uncorrected version that was taken in camera. Probably the setting that they used in camera was way too cool for the environment. So there is a blue color cast happening here. You can see that the color is really like dull. The pink is not as pink as it was in person, whereas you can see that the color cast on the left was corrected. The color cast has been removed. It's a lot warmer and much more natural to what you saw in the environment. Another example here with orange or warm color cast happening. You can see that on the right, there's an overall wash of this like yellow-orange. And then on the left, the color has been corrected to the best of this person's ability. So you can see that the whites of the pathway are more closer to white than they are in this image on the right side, sorry. So like to kind of talk about this a little bit more, I think more could have been done with this image because the white of the pathway, the white in the sky, it's still not as white as it would have been. But again, I wasn't there, I didn't see it, so this all determines on the actual environment when you saw it. You want to emulate that when you color correct. Of course, we can like also edit things and make things more dramatic as well, because that's like the beauty of editing. But always starting with a good base of editing your photos um, to the point of how you saw it, and then going from there. So what we can see in this image is that there is a sunset happening where you see the lot of like the purple, pinks, oranges in the sky. That pink is reflecting into the pathway here. So that could have been another thing to try to remove a little bit, but then anything you remove here will also be removed up here. So that's also another reason why I'm sure that this person kind of stopped there. But yeah, you can see that the pathway is also looking pretty pink because the environment of this area was pink at the time. So I hope that explains things like there is always light around us or different sort of elements like this grass here. I even see little areas of green in here because that's also reflecting into the whites of this image, green and pink and orange as well. So this image is a little bit more complicated to color correct because there's so many colors going on. So I hope that's clear. We want to do our best to get the image to what it looked like in person. Um, and basically just correcting any color cast that happened to the best of your ability. So I talked a little bit about color temperature, and we're going to go a little bit more into that right now. So color temperature also gives off color cast. I had mentioned that this image, for example, was shot with the wrong color temperature in camera. So you have to decide, besides auto white balance, what other color temperatures can you use in your camera? And this also is color temperature with actual light bulbs, as seen in this image. When we are in our own home environment or when you're at school, lighting looks really different, right? So like usually at home, you've got this warmer light, but at school, you've got something a little bit cooler to try to keep everyone awake. Or in hospitals, like the color of the light bulb, I don't know, this is giving like hospital vibes with the green colored light, this like really cool green colored light. So yeah, depending on the space and your environment, lighting will always change naturally, artificially, and through your camera as well. So what you should know is that color temperature is measured in kelvins. The lower the color temperature, the warmer it is, and the higher the color temperature, the cooler it is. So here's a Kelvin color temperature scale. As we can see, there's a lot of different numbers here. So like I said, the lower the the lower the Kelvin degrees that's happening here, the warmer the light, the higher the Kelvin degrees that are happening here, um, the cooler the light. So we can see that candlelight is around 1500 Kelvin degrees. Tungsten light, which is like a warm light, that's also something that you'll see as a setting in your camera. That's around 2500 degrees Kelvin. Household light bulbs, usually around 4000 Kelvin degrees. Electronic flash. Overcast daylight, which we saw in the very beginning of this presentation, around 7000 Kelvin degrees. Blue sky, 10,000 Kelvin degrees. So like I said, your environment, the lighting, literally the lighting that you choose to get for your home or for your place of work, etc., you're choosing which kind of light you want. So as you can see, really warm light, 2000 to 2500, just regular warm light, which is like in between. You can see it getting a little bit higher here, so 2500 to 3500. It's getting more to the cold zone. Then we've got natural white, 3600 to 5000 Kelvin degrees, and then cool white, 5100 to 20,000 Kelvin degrees. So hopefully you can see that the Kelvin scale includes, of course, artificial, natural light, but it also applies to the settings in your camera. So choosing your white balance. We have auto white balance here, which again, I said, go ahead and use that in the beginning. Now go ahead and play with the different settings. Choose different settings for the environment that you are in. So that would be daylight, cloudy. We've got flash right here, sorry, and tungsten, etc. I believe this one's tungsten. So look for the white balance on your camera, play around with which setting you would like to choose, and I've got a little grid of information about which ones you should be looking for. So I will have this presentation as a PDF, so you can look at these and spend some time with them. But they're just all different types of examples about like what the Kelvin degree is aiming for and what the goal is for that lighting condition and how it can render those colors. So a question to answer here is, why is tungsten blue? So in the next few examples, including this one, you'll notice that tungsten specifically will look really, really blue in certain images. And it's really strange because tungsten is supposed to correct warm light because tungsten is warm light. So what it's doing is that it is meant for warm light that's between 2500 to 3500 Kelvin, and it's neutralizing the strong yellow-orange cast, which thus causes the image to shift to the blue cool end of the spectrum if the environment is not warm. So this indicates that the wrong temperature has been chosen for the environment. So you'll always know when you're looking in camera, if you're like comparing in-camera view from your viewfinder to looking out into the natural world with your eyes, like just peeking away from your camera and looking out in the environment, how the camera is rendering the color versus how your eyes render the color. And you want to match what you're seeing in real life. Another example here, we can see that auto did a pretty good job within this environment. I would say that looks pretty good to how you would see this environment. Then daylight. It does look like daylight, but daylight actually would be a little bit incorrect because actually there's a little bit of clouds happening there. So the color in this camera, when they're photographing this environment, is coming out more cool, more magenta, more purple. And then cloudy looks pretty good too, but also a bit warm. Tungsten is fully blue because this is not a naturally warm environment, right? The sky is blue, so it's turning the image really blue, trying to correct a warm light that's not there. And then fluorescent does a pretty good job as well, which is interesting because fluorescent is meant for fluorescent lighting, like artificial light bulbs, but it actually doesn't look too bad. So actually, I would say fluorescent does the best job here because look at the streets right here. It looks really gray and not like, it doesn't have that like kind of yellow cast happening here. Yeah, it looks pretty balanced. I would even say I can't tell if it's like a yellow cast or a green cast that's happening, but probably leaning more towards green because of the sky, so it's like a little bit cooler. But yeah, fluorescent looks pretty good here. So hopefully that's clear. Like in your camera, you'll choose the different settings. Let's move away from auto. Choose daylight, cloudy, tungsten, fluorescent. Choose the different settings on your camera. Play with them for the environment that you're in. If you're in a cloudy environment on a cloudy day, use cloudy. If you're in the daylight, where there's not a lot of clouds, try daylight. If you're in a warm ambient environment, use tungsten, etc., so on and so forth. Another example, this may be a little bit more clear than the other example that I had of the grid showing you what these different modes do and the temperatures, just because the other one didn't list exactly what the setting was. So as you can see, auto white balance is between 3000 to 7000 K, and daylight is at 5200, shade, 7000K, so on and so forth. We also have custom, which is a setting that you can choose on your own. So that's you determining what you want to set the white balance to. And you can definitely play around with that. I usually personally just stick to what these have. Like if I'm using a flash, if I'm using strobes, I'll use the flash symbol. Um, I do use auto white balance because I think it does a pretty decent job. A lot of other photographers will have probably disagree with me a lot, but because the range is only from 3,000 to 7,000, but I think it gets me to where I need to be. I don't have to choose between these. The assignment for you is, since you're new to photography, play around with these. I want you to explore these. Know that auto white balance is there. Different teachers have different ideas of if you should use auto white balance or not. I'm personally okay with it, but I do want you to use these and try them out. And then custom, you can play around with that as well. If you're really good at like numbers and understanding Kelvin degrees and like really fine tuning the color white balance, this would be for you. So we can see 2500K would be the tungsten light type of setting. Um, this environment is not that blue, and so what it's doing, it's trying to cast a blue type of filter on top of this warm environment. And yeah, so it's turning out really blue. And what I meant is that this environment is like a lot, uh, it's not as warm as it thinks it is. And so that's why it's turning really blue. So here at 5000K, pretty good, pretty balanced. It's like right in the center there, not too cool, not too warm. So pretty decent setting here. And you can see at 10,000K where it's really cool, the actual color temperature, right? The higher the Kelvin degrees, the cooler the temperature is. This environment is not that cool. So the filter that's happening that we see here in camera is really, really warm. So it's doing the opposite. So in a warm environment or an environment that's not warm, it's going to be really, really cool. And this environment, since we know, is kind of in between. When you're making it to 10,000K here, it's turning the image to be really the opposite, which is really warm, when actually this number here is for a cool day. So more information here for you to look at. Again, the PDF will be attached, but like you can see, auto white balance 3,000 to 7,000K. It really has, it doesn't go beyond 7,000K. It doesn't go below 3,000. So there's a lot that's not being able to be captured in terms of white balance. So it can capture certain areas and environments in the wrong white balance. So for example, like a candlelit environment is at 1000K. It might not be able to capture that correctly. Whereas, like we had mentioned before, something like 10,000K, that might not be able to be correctly rendered in the camera due to white balance, because auto white balance has a range. So here's another example in Studio between auto white balance, the flash white balance preset, and then custom white balance. As I said, in the Studio, you can see that um, there is white light, white strobes that are being used. And when you're using auto white balance, it has a range. So it's kind of giving off this really blue cast. So I would say the person's skin color here does not look true to how their skin color actually is. Same thing here, flash white balance preset does a pretty good job actually. Um, yeah, I would say flash white balance does probably the best job at capturing this person's skin color, of how their skin color would look like in real life. You can see more of their like orange glow, yellow undertones in their skin coming out, because the flash white balance is correct to the flash being used. And then custom white balance, they set this to be a lot warmer. So you can see that in this image, the image, sorry, their skin color is looking a lot more rich, but I'm not sure. I haven't seen this person in person, so I don't know if which one's a better example of what their skin color actually looks like. But I would say these two for sure look the best, and then auto white balance really doesn't capture their skin color as well. It's just looking very, very cold. So the next thing that I'll be talking about is a gray card. A gray card is used to neutralize an image, and it's called a medium and middle gray, and it's usually at 18%. So this is commonly used to set the custom white balance in your camera, specifically the 18% gray card. So when you're adjusting your exposure, often you can do that in camera and point at the gray card and try to find the right color temperature by setting this gray card and your custom white balance setting in camera. So what your camera sensors will do is that they basically operate at an 18% gray, and they'll try to understand the light reflected off of the card to then give you the correct custom white balance. But in post-production, this can cause color cast at 18% gray. So again, the gray card here being used to set the custom white balance in your camera. Here's an example of that. So you can see 18% middle gray. This is what it would look like. And then we also have a white balance card. So this is meant for post-production. I would say for the beginner user, this is great. And this is the method that I use, using a white balance card. So this aims to get colors as seen in person, and whites to be as close to white as possible without color cast. So you're neutralizing the image so that there's no extra color cast happening, that the colors of your image are as close to how you saw them in person. And this image, you can see there's a black, white, and gray combo card here. So this is meant for shadows, the blacks, the mids, which would be the gray, and then the highlights, which would be the white. So that's how you would use that gray card. And this is the one that I'm more familiar with. This is a gray card that a lot of professional photographers use. This is about, the last time I checked, $50, so pretty expensive. I would say this is only really necessary if you're using this in studio. You can also use this outside of the studio, but it's great for in studio use. There's a lot of different colors to choose from. This is the one that I usually stick with. So this tone is more like middle gray, something you would use for to figure out your exposure in camera with your custom white balance. This is something more like 70 to 80% gray, as I say here, which is more like a white balance card. So this X-rite color checker passport has many ranges of colors and grays for all different purposes. Like I said, it's used more by professional photographers and in studio settings with studio lights. Like I said, have had luck with this one. I feel like this color does really, really well, this tone of gray. Because it's closer to white, but it's not actually white, that I think that it can really just render the whites and the color temperature, color cast, all of that really well when you're editing in post-production. So I spend a lot of time here talking about the color checker just because it might not be something that you're used to seeing. And I think that the colors are really interesting. Honestly, I have not really played around with any of these colors. I usually stick within this range, or like I said, I stick with this lighter gray color here. So as you can see, 1, these patches represent skin tones. 2, there's blue sky and green foliage. 3 is natural tones and secondary colors, all of these colors here. 4, this represents RGB and CMYK, or CMY more so. K is black, so that is not represented here. And then 5, these are all the different types of neutral gray. So like 18% gray would probably be around here, or like in between these two. So you can see there's a whole range of things, or a whole range of neutral grays for you to choose from, a whole range of percentages of neutral gray. So like the one that I use, which is like 70 to 80%, would be closer to this range here, whereas middle gray, 18%, would be more like around here. And you can see that when you select these different areas in Lightroom, which I'll show you how to do in a second, um, or not in a second after this presentation, but you can see how they change the look of the photo. So this one is looking a lot cooler versus this one's looking a lot warmer. And I think this image looks a lot better. Um, versus like different environments here. This image looks a lot cooler versus this one's a little bit more neutral. So if you don't have a white or gray card, no problem. So we're going to be using this eyedropper tool. And in this eyedropper tool, we basically, in your image, will select a neutral tone, or what was a neutral tone before it had a color cast on top of it. You can see in this image, this before color cast is pretty green looking. And after color correcting it with the white balance eyedropper here, it looks a lot more as seen in person. The color is more true to white here in the sign, and just overall all over here. Like in the pillow, you can see that it's more white, and more true to white. So like I said, you can look for neutral tones in your photo to get your whites close to neutral white, and you don't need a white or gray card. I don't want you to get so hung up on the white or gray card. I think going back here, you can definitely use something like this, any sort of white balance card. Play around with this. These are like $10. I don't think you need this one. So you can also play with your white balance in this section next to the white balance eyedropper. And there's a little drop down and you can choose the different selections there. So they also look like what your camera settings have as well. Now going into hue, saturation, and luminosity. Here we have the color wheel. So the color wheel is made out of red, magenta, blue, cyan, green, yellow, and black. In the middle here, so this is otherwise known, hue, saturation, luminosity is known as HSL. Hue is like examples of red, cyan, hot pink, and royal blue. Oh, I'm sorry. Yes, that's correct. I thought I was reading the other part here. Saturation is hot pink, has more saturation than baby pink. Royal blue has more saturation than sky blue. Navy blue has less luminosity than royal blue. So navy blue has less luminosity than royal blue. Royal blue is brighter. So I'm going to fast forward a little bit. So I should have put this a little bit higher in the presentation. Now that I'm going through the presentation, it feels like this should be higher. So I'm just jumping to this. If it wasn't clear, hue is a technical term for color. So red, orange, yellow, green, blue, etc. Saturation is the hue color intensity. So it can be really, really all the way to bright red or all the way down to gray. So totally desaturated. Luminosity or brightness refers to the lightness or darkness of colors, making the color really light or making the color a lot darker. And then coming back to here, complementary colors. Complementary colors are opposite from one another on the color wheel. So red and cyan are color complements. Yellow and blue are color complements. Green and magenta are color complements. So we use complementary colors to manually white balance. And I'll show you how to do that later. Analogous colors. I love analogous colors. They're so pretty together. Basically, it's colors side by side on the color wheel. So from green to yellow, yellow to red orange, red to purple, blue green to blue purple. Sorry, this image is not that great, so you can see the quality kind of fading out here in the text. And sorry about that. But you can see that the colors side by side, they look really harmonious and soothing. And so if you ever want to do some sort of like just color theory in general, analogous colors are really great to start with when you put the same colors in a certain environment, or you light different subjects with these types of colors. The colors really play well with each other. All right, so color correction for editing and printing. You will determine the color cast of the image and then add the complementary color of the color cast to neutralize it. So yellow and magenta make red, and blue and green make cyan. So when you have an image with a red cast, you can neutralize the cast by adding equal parts of blue and green. And when you have an image with a cyan cast, you can neutralize the cast by adding equal parts of yellow and magenta. And then lastly here, before I get into some examples, we have just a sheet here that talks about the differences between RGB visible light and CMYK. So RGB visible light is basically an additive environment. So we can see basically the RGB color system in digital cameras, in your monitor, and anything that has a screen that is RGB based, whereas CMYK is really strictly for printing. So this is subtractive. The more color used, it equals out to black versus additive for RGB. The more color used or altogether is going to equal out to be white. So when you do move from RGB to CMYK, like if you took this class in person or if you take other classes in person where you print your image, you will notice that a color cast will happen from RGB when you photograph your image and you edit it. And then when you print it out, the color may look different because they're using two different types of color spaces. So RGB moving into CMYK. CMYK can't always render what RGB has because there are different colors and they're different color spaces. So like, for example, if you print on an image and it looks a little bit more magenta, then you would have to get rid of that magenta cast that's happening when you print it out. So you're trying to then again edit on top of your image to get the color cast out. So when you print your image, it looks like how you see it on screen. So here are some examples. You don't necessarily have to worry about this. I just wanted to explain it to you. But if you do take classes in person and you do want to print off your photographs, or maybe you take your photos and you get it printed out at Target or Walgreens, CVS, etc., you may notice that it might look a little bit different. So we've got a couple images here to go through, and I'm going to edit these images. And I'm also going to ask you to edit these images for your assignment. So these images need to be color corrected. They need to be white balanced. And yeah, so we'll go through these examples in the next video here. But these are the images that you'll be working with. And in this image particularly, you can see there's a really big green cast that's happening. So we want to remove that. Same thing with this image, is also leaning more cold. This is, you can see the background is really yellow. So this must have been done right when golden hour left. So the image is really cool. And I think I want to warm this up a bit. And then this image is very, very warm. So though I think it looks great to the environment, just as an example, let's try to neutralize this. Make it so it's like warm, but also a little bit not so warm overall in the image, and see how we can do. So in the next video, I will go into how to edit your photos in Lightroom.